Hello and welcome to this already 6th episode of my Hibernate Reactive and Vertx tutorial. So this episode and some other episodes that will come next, they're mostly optional because we finished talking about Hibernate Reactive, and in this episode we will not talk about Hibernate Reactive, we will not talk about data layer. Instead, I would like to make our project, our application that we started in this series, to make it more complete, to make it more real life. And the important step here is actually to implement a REST API with our application. Of course, there will be no Hibernate in this series, but it's still very important episode because we will talk about how to connect what we did with Hibernate and how to make it accessible by clients. So, if you follow this tutorial, you already see that I follow the idea of layer-based architecture, or also it is called tier-based architecture. So the idea here is that we organize technical components inside different layers based on their technical functionality. So, for example, we could have data layer that we implemented with Hibernate Reactive, we could have a service layer, etc., etc. So the classical approach that is this is coming from Java EE. However, it's not a Java specific because it's also implemented in other technologies as well. It's called a 4-tier architecture. So basically we have 4 tiers here. We have a data layer, we have a service layer, also it's called a business layer, we have a web layer, and we have a presentation layer. So the presentation or view layer is a bit tricky one because actually in modern cloud systems, we decompose it from the web layer, and it's actually live inside a client-side application, which could be a mobile application, single-page applications, or even desktop or CLI tools. So basically, view layer is something that is isolated from our Java code, and like the top one would be a web layer, the layer that we will implement here. So let's briefly talk about functionality of the web layer. Okay, the quick distinction between a web and a view layers. So we need to separate these two concepts, and especially because in the previous days, when we talk about view layer or presentation layer, basically it lived inside our Java application or any other server-side application. Today, of course, we separate the things. We have separate client-side applications that actually constitute to the view layer of your project, of your system, because it's not only like a separate application, but we have like bunches of services, a bunch of client-side applications. Talk about a cloud system, not just a single application. So in cloud applications, the web layer exposes unified APIs that is defined with some specification. Usually we talk about REST, but it also could be a GraphQL or other solutions, and it's a separate topic of how to use a GraphQL with Vertx. And in this series we focus on the REST API. The view layer is separated from the server-side application, and as I said, it usually lives inside mobile, desktop, web application, etc. So it is usually encapsulated into different applications that are implemented with different types of architecture. Usually this architecture depends on the vendor, so there are different approaches to implement applications on Android. There is a separate approach on how we do it on iOS, and the different SPA frameworks also have different ideas of how we implement web applications using them. So as I said, most common option is to use REST API, and usually when we talk about web layer, we talk about synchronous HTTP protocol. Well, there is also a possibility sometimes to use, a necessity actually, to use asynchronous communication such as WebSockets or TCP/IP protocol. For example, when we need to have a real-time communication between a client and a server. It could be like a chatting, it could be notifications, or some kind of like data that should be updated in real time. So in this way we use asynchronous protocols, but usually we talk about REST APIs that is served over HTTP protocol, so using asynchronous communication protocol. Okay, so what actually is a web layer in cloud applications? We could define a web layer as a group of technical components that are responsible for request handling, routing, server-side validation, error handling, and response handling. So usually we utilize what is called resource-based approach. So we have like different CRUD endpoints with a number of methods to manipulate the data in this fashion. Such we have like projects, tasks, users, you name it. It is a good practice to implement access control mechanisms as well in order to provide like a more robust security based also not only on authentication mechanisms but also on some business rules, like we did in the previous episodes when we talked about object level permissions. A quick note that in this particular section we will not implement object level permissions, and I will give a small note later on in this video, but because it is a separate topic of how to do authentication using Vertx, and I would like to keep things more simple and more focused on a web layer, not on authentication. But I highly suggest you to check my book Principles of Vertx 2nd edition, where I talk about different authentication mechanisms using Vertx and how to build them in your systems. Okay, so what is the Vertx Web? If you go to the Vertx documentation page, right after the Vertx core, which is the most used Vertx library, you will find the second most used library, which is called the Vertx Web. Let's go to its documentation. So here you can find that the Vertx Web is defined as a set of building blocks for building web applications. But it's also very important to remember that basically the Vertx Web is more like an abstraction that is used in order to make our developer life easier, but actual low-level networking functionalities such as HTTP and TCP/IP handling protocols are implemented inside the Vertx core. And when we use a server, it actually comes from the Vertx core library. So the Vertx Web library provides us a rich set of functionality, and you could see that we have here routing, body handling, forms, file uploads. We also could have here a course, error handlers. We could also have templates if you talk about server-side applications. You could also have static file serving, which is also important when you have like single page application that is running on your Vertx server as well, such is implemented with Vue, Angular, or React. And you could find also a separate video on my channel about this, or you could get more information in my book Principles of Vertx 2nd edition. You could also even find here SOC.js support. But this is always very interesting. But let's go to the left panel and let's select the basic Vertx Web concept section. So here you have this code snippet. And if you're coming from micro frameworks such as Flask, such as Express, such as Sinatra, Spark Java even, you will find this code snippet familiar to you. But if you're coming from MVC frameworks such as Spring, MVCs such as Django, such as Laravel, Ruby on Rails, well, you will find this a bit overwhelming. But let's go step by step. The first thing, you need to create a server. The step that is familiar for micro frameworks developers, but this is something that you will not directly do in MVC frameworks. This is what the framework will do for you. But here you create a Vertx server, and note that in order to create a HTTP server, we use a Vertx object because HTTP server is actually part of Vertx core library. The second thing is to create a router, and the router allows us to have different route handlers and provide functionality for them. And also, when we talk about route handlers in Vertx, it allows us to have what is called route chaining. Again, thing that's familiar for micro frameworks a lot. When we talk about route chaining, of course, we will not do it in this particular episode, but in my book Principles of Vertx 2nd edition, you will find a lot of it because this is very important technique when you want, for example, implement authentication. So route handler allows us to have an access to what is called the routing context. And basically routing context is an abstraction as well that allows us to manipulate HTTP server response and HTTP server request objects directly, or to have some helper methods in order to, for example, do common web tasks such as getting body from the request or write data to the response. And it is important here to check this end methods because when we talk about routing handling, routing chaining, we basically could pass the information to the next route from the one route. But when we use the end method, usually we say, no, end this cycle, stop here and write data directly. So we use the response end method in order to finish this request response cycle. So finally we use the server and we attach this request handler. So as a request handler we use this router. So basically all incoming requests that will come to the server, they will be checked with this routers, and then router will find the appropriate handler, or that could also find the default handler, could find error handler. Again, this is a topic that's a bit out of my this YouTube series, but you could find more answers on it in my book Principles of Vertex 2nd edition, for instance. And finally, we use this listen method. And again, if you're familiar with micro frameworks, this is what you do always. You use this listen or start or any other methods like in Flask, Sinatra, Spark Java, etc. But again, this is not what you do in MVC frameworks. And it is important to note that this listen method is actually an asynchronous feature, so we need to attach handlers to it in order to use this method in order to check that the server was deployed correctly. So this is basically a very, very helicopter overview of what is done under the hood in our project. So it's only very important to remember that we do these things manually, and some concepts that you are familiar with MVC frameworks such as Spring, they will not work here directly. But if you have an experience with micro frameworks such as Express, again, Sinatra, Flask, etc., you will find Vertex a very familiar experience. So let's now go and let's open our IDE and let's start coding. Okay, just a small note before we'll begin. In the previous episode, we implemented what is called object level permissions inside the project service component. But when we talk about a web layer, actually in order to implement object level permissions, we need to have this principal object. In other words, we need to have authentication system. And because these episodes will be very big and will have a lot of content, I decided to remove this functionality and to introduce what is called a simple project service. So basically this will be the same component, but it will not have a principal. So if we go here to simple project service implementation, you will find that it's very simple solution that's just basically a bridge between repository and the web layer. So in a real life scenario, of course, I suggest you to implement an object level permissions. But in this particular episode, again, because it will be a lot of additional complexity already, I would like to strip this functionality down and to use this simple project service component. Okay, so without further ado, let's finally start coding. We already have several packages in our project, and let's create another one. And I would like to call this package web, because here we'll allocate different components that are responsible for web layer. And the first component that I would like to create would be a Java class that I will call a WebVerticle. And just a small note, we could not use records here because we need to extend an abstract vertical class from Vertx core library, and we could not use extension with records. So we need to create a simple Java class. So let's add it to Git, and what I'd like to do here, I would like to extend an abstract vertical class, and now we will have all functionality that is provided by this library. So the first method that I would like to override would be a start method, and you need to select the first one that has a promise as an argument, because we use this promise in order to tell to the Vertex that that the vertical was successfully deployed or not. So let's remove this boilerplate line of code for a moment, and what I'd like to do now, I would like briefly return to the documentation, and here you have steps that we need to implement. The first is to create a server, then to create a router, specify routes, and finally to start a server. So let's implement them step by step. So the first thing first is to create HTTP server. And note that this method comes from Vertx core library, as you could see on this on this tooltip. So next we create a router, and in order to create a router we use this router static method that accepts the Vertx instance. Then we need to specify routes, but before we'll do it, let's finish the cycle and let's start the server. So what we will do next, we use the server request handler, and we pass here the router as this request handler, and then we use this listen method. So this listen method is actually it returns a future, so we need to subscribe on it like we did in all previous episodes, and we use onSuccess, and this means that the server is up and running, and we could say that that the vertical is successfully deployed. And on failure, we just tell to the Vertx that something happens and we could not start the server. But before we will do it, you could see that the listen method is actually accept an integer value. And the integer value here is the server port number. Of course, when we talk about cloud application, it is always important to isolate things from a code. Even such a port number. How we could do it? Well, we could pass it inside a constructor. So we could create a constructor and then use what is called construct-based injection, even without dependency injection framework, but just to pass as a constructor. But when we talk about verticals, we actually have what is called a deploy method that allows us to provide a deployment configuration. And in order to access it, let's comment out this a line of code quickly. We need to check it by using a config method that comes with abstract vertical. So let's get a JSON object and we call it config, and then we use this config method that returns this this configuration. And then we say integer port, we say config get integer, and we say here a port. And now if we comment out this again, so when we say listen, we pass this port value, which is now isolated from the code, and we provide onSuccess handler, so we say here result, and when we use it, we say start promise, complete. So in this way we tell to the Vertx that server is up and running on this particular port. And we could also specify a failure handler, and this way we say here fail. So in this way we could notify the Vertx that something is going incorrectly. So now we have this basic flow, and what we could do, we could actually try to run it without route handlers, because what I'd like to do here, I would like to check that the vertical is successfully deployed. Okay, just for demonstration purposes, let me run this code, this vertical, with a very quick and dirty solution. So we will not write a test in order to verify that our vertical is successfully deployed. Instead, what I'd like to do, I would like to create a simple main method. Of course, main method is not what you need to use when we talk about Vertx, and we will talk about this topic in the different videos. And I also suggest you to check my book Principles of Vertx 2nd edition, where I talk about different options of how to deploy Vertx applications. But here it is what we could use just for quick and dirty demonstration. So let's create a Vertx instance by using Vertx static method, and then we will instantiate a vertical. So actually we need to say WebVerticle, of course, and we use this new WebVerticle method. So it is important to remember that once we instantiate an object, we just instantiate an object. This start method is what is called by the Vertx when the vertical is deployed. So in other words, this start method would not be executed until we will actually deploy the vertical. But remember, we have here a configuration, how we could pass it. So we use the deployment options for this. So let's instantiate the deployment options, and let's provide a configuration. So let's say JSON object config, and it will be a simple JSON object that will contain some configuration. In our case, it is a port. So say config put a port, and will be 8080. So it is also important to attach this configuration to the options object. So we say here config. And now what we will do, we say Vertx deploy vertical, and we pass here vertical, and then we pass options. And again, this is a future, so we could specify onSuccessHandler, and what it will pass an ID of the vertical once it will be successfully deployed. So we say here ID, and we use this out method. So we pass here an ID, and we specify onFailure method. So onFailure, what we will do, we will just print a message. So let's run this method and let's see what will happen. So we will have this ID, and we started this loop. So actually we need to use this ID in order to kill the verticles or undeploy this, but we will just use this stop signal in order to finish our application. So basically now we see that our server is deployed, so our server is up and running because we call this start promise complete method. But of course we need to make something more useful here, and what I'd like to do here, I would like to specify route handlers for methods that we need to have in this application. Okay, so it was a quick and dirty example with the main method, but my purpose here was to introduce you to the idea of deployment. In other words, in order to run the vertical in the Vertx world, it's not enough just to instantiate a class. No, you need to run this Vertx deploy vertical method in order to execute this start method and to run this start logic. So in our case, in the case of WebVerticle, we have here what is called server creation. So another example, if we have, for example, a data vertical, because in our project we separate the data layer component into a separate package, but if we'll say we have a data vertical which is connected with a web vertical using an event bus messaging, so we will also specify this event bus handlers inside the start method of the data vertical. So just to make sure that we're on the same page and we understand what is the deployment. So now what I'd like to do, I could delete this main method, and as we here in the WebVerticle, we also need to provide a dependency. We need to provide a dependency for the simple project service, so let's add it. So let's make a new private final simple project service class variable, and we call it project service. And then what I'd like to do, I would like to go to the generate menu, and let's create a constructor with this argument. So now everything is okay, and we could create our API test. So inside the test package, let's create another package, and likewise with the main package, we'll call it web. And here we will allocate a new Java class that is called WebVerticleTest. And it is a good practice also to make your test with the default access modifier. So let's delete this public access modifier, and let's extend this class first with a Vertx extension like we did previously, and the second would be a Mockito extension. So why we have Mockito extension here? Well, in the WebVerticle we have this dependency. So in API tests, it is a good practice still to mock your dependencies using Mockito or any other mocking frameworks. Of course, when we talk about end-to-end testing, we will substitute this dependency with the real simple project service implementation. But because API test is basically something between integration tests and unit tests, we will use mocking framework. Well, because when we talk about integration tests like we did in the data layer testing, what we had here, we had an external dependency, but here we don't have actually an external dependency. We just want to validate that all our web layer components work as expected. So for this, we will mock this dependency. Hope this will make sense and we are on the same page. So let's go back to the WebVerticle test. So now let's create a mocked variable of type simple project service, and we'll call it project service. And then we will inject mocks into our WebVerticle, and we call it here a vertical. And again, it is important that by using this inject mocks, yes, we will instantiate our WebVerticle with this dependency. But of course, Mockito is not calling this start method, and we need to do it manually like we did before. So another thing that I'd like to add here is a web client that comes from the Vertx Web Client library. So just a brief introduction to this idea. So if we will go to the Vertx Web Client documentation, you could see that the Vertx Web Client is a separate library that provides an asynchronous HTTP and HTTP2 client. So the web client allows us to have lots of functionalities such as body encoding, request response pumping, request parameters, error handling, form submissions, etc., etc. So basically, it is based on the Vertx core HTTP client, and it provides much more robust and fluent and synchronous API that is really useful for API tests. Just a quick note, because if you're coming from frameworks such as Spring MVC or Django or any other frameworks that have these built-in test web clients, you need to remember that the Vertx actually does not have this separate test client, and in our API test we will use this real-life web client. So let's go back to our IDE, and what I'd like to do now, I would like to run a setup method. So in the JUnit 5 world, we use for this a before each annotation, and we specify here a setup method. So like any other methods in a Vertx testing world, we need to provide a Vertx argument and a Vertx test context. So just a quick note, because like we did it in the data layer, for example, let's go, for example, to the project repository implementation test. And you see that the Vertx argument is always gray. That means it is not used. We just use this a context argument. But in this WebVerticle test, we actually would use Vertx because we need to deploy this vertical. But, and this is very important, if you remember our code, we also need to provide this configuration. So the first thing first, let's create a deployment options object. And we need to create a configuration. So we say vertical config. And we create a new JSON object. And here we need to specify this vertical config. And here we put this port argument. So let's just double check it. Inside WebVerticle, our key is called port. So let's go back and let's specify a value 8080, and then we call options set config, and we provide a vertical configuration. Now what we could do, we could create a client instance. So we say client web client create, and we'll use this Vertx object. And then we could deploy this vertical, because again, in order to deploy, we need to call Vertx deploy vertical. So it's a Vertx deploy vertical, we pass a vertical here, and then we specify options. And then we could provide on success. And in this case, we say context complete now. That means that the context will go to the next another method, another test method, because the before each that means that we the life cycle of this setup is just one test method, not the whole test case. And then we provide on failure handler, and in this case we say context fail now, and we provide this error. So now we have everything set up, and we could use this before each and use it in order to run everything that we want. So now let's go and let's actually set up the router handlers, and let's see how we could implement them one by one. Okay, so an overview of what we will build in this episode. In previous episodes of this series, we have implemented a business logic component. So we have a service now that has methods to create, update, delete, or retrieve data. On the web layer, we will have what is called a WebVerticle pattern. So if you're coming from a Spring MVC or any other MVC framework, perhaps even with WebFlux, with Spring WebFlux, it will work this idea. but usually we talk about MVC frameworks like Spring MVC, Laravel, Django, etc. So if you come from these technologies, you will know that we have what is called a controller pattern. So we have a controller, basically is a bridge. The controller is a bridge between a web layer and between a service layer. And because we don't have a direct access to a web layer, we don't have access to server, we don't have access to router directly in these frameworks. So we define these controller methods that basically are route handlers, or they basically do some stuff in order to connect with the service layer to handling request and response. But actually it's not a low-level handling of request and response, and we could not say that it is 100% the web layer component. So controllers are basically something in between. On the contrary, when we talk about WebVerticle, we will have an access to the server, we will have access to router, and actually methods that we will define in this vertical, they are route handlers. So they will be directly route handlers, and we will have an access to request and response, and we will handle them manually, unlike what we have in MVC frameworks when we don't have this access and we work with abstractions. So there are different approaches of implementation of WebVerticle, and this is not the only one that we will use here. For more information, I would suggest you to check my book Principles of Vertx 2nd edition, and the link is provided in the description for this video. Okay, so now let's start with route definition. And unlike what we did previously when we start with create methods, now we will start with retrieve methods, and shortly you will see why I do this. But for now, just let's start coding. So let's just maximize an editor so you will get a whole picture. And after router, I would just like to add some empty lines in order to make things more more visible. So we say router, and then we have different methods. We could use either a route or we could use a shortcut method. In our case, I prefer the shortcut method, that is get. That means that we expect a get HTTP method, and let's specify its address. So addresses are started with a backslash, and we say projects, and then we need to specify actually a path variable. So what does it mean? Actually, we also need to provide the definition here. We need to say 1 because we don't have principal, just remember this, and we need to distinguish between a 1 and a user, but just a small note because we have a very simplified version here. So anyway, we need to provide a path parameter. If you're familiar with Spring, we use curly braces in order to distinct path parameter, but the syntax in Vertx is different. Now we have the access to this ID variable, and then we provide a handler. You see that here we have this routing context tooltip. The routing context object is what we have talked previously. So now let's start to utilize it. I provide curly braces because I want to have several lines of code. We expect this ID, but ID is actually a type of string. So what we need to do, we need to convert it first. So we say integer ID, and then we say integer get integer, and we specify here context path parameter, and we say here ID. So now we have this ID because if you remember, in our simple project service we expect here to be an integer. So now we could use this project service in order to retrieve this this data. So we say project service, and we have here findProjectById. So remember that we actually have here a future, so we could specify on success and on failure. So we will start with on success. So on success we will have a result, and remember, and it's very important, that result is actually a type of optional. So if we go back to the definition, you see we have here an optional. So because we could have this value or we could not have it. In our case, if we don't have, we need to return 404 response. And it is very important to note here because this 404 would be inside the on success handler, not inside on failure handler, because technically it's not an error. It is a logical error. I would say it's better to say it's business error, or business failure situation, because strictly it's not an error, just an absence of data. But in any case, it's not a technical error, so it's not possible. Well, it's possible by raising an exception, you could move it inside on failure, but you should never do it. For more information about error handling and different cases, I suggest you to check my book Principles of Vertex, 2nd edition. But for now, let's deal with this result. So we will use all good if methods and if construction, and we'll say if result is present. In this case, what we will do, we will say context, and actually we could use this JSON object first in order to get a body. So in this way we say JSON object, and we have here map from static methods where we pass result get, and then we say context response. We provide a set status code, in our case it will be 200, and then we say end. And inside this end method we will finish this request response cycle by using body and code. So another situation would be if the data is not presented. In this case we say context response, we set status code to 404, and we just end this this request response cycle without any data. We don't write anybody here. So now we have this on success handler, but we also could have on failure handler. So let's say on failure, and what we have here, we just have context response set status code 500, and we write end. Well, basically what you could do and what you should do when you go with Vertx, actually not only Vertx but any web framework, you need to provide a unified explicit error handling. For more information about error handling, I suggest you to check my book Principles of Vertex, 2nd edition, or one of my courses on Vertex. But in this video, in this series, we will keep things simple, and we will not provide an error handling, a separate error handling. So we will do it just this naive implementation. So now basically this is all for this handler, and we could now go and we could write an API test for this first route. Okay, so now we're ready to write an API test for this handler. So remember, we have two test cases. The first one when data is presented and we return the status code of 200, and the second when the data is not presented and we return status code of 404. So let's go to the WebVerticleTest. As with any tests that we wrote so far, we start with this with the same definition. So we say find the project by ID exists actually test, and we specify here the vertex argument and the vertex text context. Now what we do, as always, first we specify a mocked data. So we say project DTO, and here we instantiate a new project DTO instance with ID of 1, user ID, and name of my project. So it could be any data you want, it doesn't matter because it's just a mocked data. Then we need to specify behavior of this project service by using Mockito. So we say Mockito when project service find project by ID of 1, and then we return future, succeeded future. And here we also need to provide an optional, so we say optional of project. Now you need to wrap the code that we want to test inside this context verify block like we did previously. So we say context verify, and we provide this code block. So what we do here, we will use this client in order to call our HTTP server. So we say client. And here, the interesting situation. So what we could do now, we could use what is called absolute methods, and we could use a normal methods. So when we use absolute methods like get apps, or you could also use delete apps, etc., like post apps, etc., we need to provide an absolute URI. In normal methods, we specify our destinations in parts. So we have a separate port, we have separate host, etc., etc. We provide separate parameters. It is more convenient if you have a lot of different routes and you need to change them time to time, because you could just have like constants for port, for host, and you just need to change the value once. However, if you work with other developers, and this is my preferred solution, is to use absolute URIs, because it's more clear for demonstration of your addresses. Especially here, because the project is very simple and we don't have a lot of routes, it is even more preferred to use absolute methods. So let's use this getApps. And we need to provide an absolute URI. What does it mean? Well, we start with a method, HTTP, and then we specify a local host, which is a host. We need to specify port, remember it is 8080. And then if we just go back here to the WebVerticle, let's just copy this address in order to avoid any mistakes, and let's copy and paste it here. So instead of this ID, we specify 1, and then we use this send method, which returns a future. And likewise with any other future, we could specify on failure, and we say here context fail now, and we specify on success. And just to remind you that this result is actually of type of HTTP response, so we could use different data from the response in order to assert it. And what we especially want to assert here, we need to assert this status code. We want to expect the status code of 200. So we say integer status code, and we use result status code. And then we use standard JUnit assertions, and we use assert equals, we expect 200, and the status code value should be 200, and then we use context complete. Now, so let's run this test and let's check that it is passed, or if we need to fix something. So let's run this findProjectById exists test, and now everything is okay. So now what we want to do, we need to verify another situation, the second situation with data is not presented. So what we'll do here, let's just copy this code snippet and just modify it a bit. So the first thing first, of course, we need to change this name to does not exist. We don't need to have this project DTO anymore, because we return here an empty optional. And then we want to verify that still our execution will go to the on success, not on failure, but the status code would be different. So in our case, it would be 404. So let's run this test and let's verify that it passed successfully. So now we implemented this findProjectById, and let's go to another handler. Okay, the next situation that I would like to implement is to retrieve several projects for a given user. Again, as you remember, when we did object level permissions, we get this user ID actually from the principal object. But in our case, in our simplified case, because we don't have authentication mechanism, we don't have a source for this principal, so we will pass this user ID inside a site URL as a pass parameter. So it is important to remember that you always should implement different security mechanisms in your cloud systems. For more information, I highly suggest you to check my book Principles of Vertx, 2nd edition, or to check one of my courses on Vertx or cloud applications development. But without further ado, let's just go to implementation. So likewise we did before, we say router get, and we start with project, which is a resource name. Then we specify user, and we specify user ID, the name of the pass parameter, and then we specify handler. Likewise, here we have here a context, a routing context object, and the first thing is to get this user ID. So we say integer value of, and then we specify context pass parameter user ID. So now we have a user ID. What we do next, we say ProjectService find projects by user, And now we specify this user ID argument, and then we specify handlers. The first one will be on success. And in this case, because we expect that we have a result anyway, even if it's empty, so not like we did in the previous case. In any way, we return this data. So what we do now, we say JSON object body, and we specify JSON object map from static method, and we pass here result, which is a type of projects list, as we did previously. So we have here this projects list model, and then we write this response. So we say context response set status code 200, and then we specify an end method. So we now have this body and code. Otherwise, if we have a failure, we just copy and paste this this handler. And again, it's important to implement unified error handling, and it's not a part of this series because it's already quite big, and actually it's not a primary focus. But I highly suggest you to check my book Principles of Vertex, 2nd edition, or one of my courses on Vertex or cloud applications development, where we talk about all of these small but very important architectural things. Well, now without further ado, let's verify our implementation by writing a corresponding API test. Okay, let's provide an API test for this findProjectsByUser. So let's go to our WebVerticleTest and let's add another test case. So let's say test findProjectsByUser test, and we specify the Vertx argument, and we specify Vertx text context arguments as well. So like we did previously, the first thing first is actually to have this list of projects. So how we could do it? The first thing first, we need to actually get a list. So we say list of type project DTO, and we have here the projects. It will be just a list of different projects DTO. So we say list of. And what we do here, we just would get this new project DTO instantiation code, and let's just copy and paste it here. And let's make it of 5 of them. And what I'd like to do now, well, we need to change these IDs because we have several of them, and now we will create this project list. So we have here new project list, and we instantiate this project list using this list of projects. So now we have this mock data, and we could specify Mockito behavior like we did previously. So we say Mockito when project service findProjectByUser, and we specify user ID which will be of 1, and then we will return the succeeded future that will wrap this projects list. So now we could specify this verify code block. So we say context verify, and now what we will do now, we will use the same code like we did before. So we use client get apps because we use absolute URIs here, and we specify absolute URIs. So we have a local host 8080, then we specify a resource name would be projects, and then we specify user 1, and we use the send method in order to send the request and obtain its response. So we specify on failure handler first, and we have here fail now of the Vertx text context, and then we specify on success handler. And remember that actually this result that we have here is of type of HTTP response, not a project list. So what we do now, we want to assert this status code. So we say integer status code, and we say result status code. And what I'd like to do now, I would like to verify that the status code here is 200. So let's go back and let's say assertions assert equals, and the expected value is 200, and then we specify this status code variable. And finally we say context complete now. So now what we do, we will run this test and we will check that everything is okay. So now this test passed and we could go to other routes definition. Okay, so the last method that I would like to implement in this the first half of our tutorial is remove method. And just in a few moments you will see why we actually group these methods in a same group. But let's just go and let's implement it. So now we define a router method using delete method, and we specify a name of the route, so we say projects, and we directly specify ID. So now we specify a handler, and we have access to this routing context. And now what we will do, first thing first, we need to get this ID variable like we did previously. So we say integer ID, and we use integer value of. And now we could use context pass parameter, because you remember that by default they are strings and we need to convert them to integers. And here we specify a pass parameter name, which is ID. And now what we could do, we use ProjectService remove project, and now because it is of type void, we don't expect any type of body written in the response like we did previously, like in these methods, but we still have on success and on failure handlers. So what we do now, we say on success, and we don't need actually to write this body, and we could directly go to the response specification. So we say context response, we set status code of 204, which is a common for successfully removed projects, so it means modified, and the end method is empty. And finally, I just would like to copy and paste this on failure specification. So again, it's not a good solution to have error handling like this, because you need actually to have a unified error handling. How to do it, you could check in my book's Principles of Vertx 2nd edition, or one of my courses on Vertx or cloud applications development, where I give a precise guidance on different architectural patterns. But of course it's out of the scope of this series because it is already a lot of content. So let's go, and without further ado, let's actually implement a test for this new route definition that we have implemented. Okay, so let's implement an API test for the removeProject handler. So let's add another test case, and it's called removeProjectTest. And likewise, previously, what we do here, we specify a Vertx argument, and we specify a Vertx text context argument as well. So the first thing first is of course to specify Mockito behavior. We don't have any return data, but we still need to specify Mockito behavior. So we say when ProjectService remove project with ID of, let's say, 1, and then we return just a succeeded future without any wrapped value. So we have a void future, but we still need to return a succeeded future in order to indicate that operation was implemented successfully, was performed successfully. And then we specify familiar verify code block, like we do always in our Vertx testing. And we use here a client, and just to note that now we use the delete apps methods, and we specify an absolute URI, which will be HTTP localhost port 8080, and we say projects as a resource name, and we directly specify an ID of 1. And now we use this send method in order to send this request, and we specify on failure handler. Here we say context fail now, and we specify on success. So what we want to expect here, we don't have any body written in the response, but we want to assert this status code. So what we do now, we get this status code, and we use this result status code helper method, and then we use assertions in order to check that expected value is the same as the value in the response. So we say status code, and now we say context complete now. So now we have implemented this API test, and let's run it. So now, as you see, this test passed. So this was a group of several methods. So we have here retrieve methods, and we have here delete methods. So what is common with all of these methods? Could you check what is common with all of them? Why we separate them from create and update? So we will get an answer in a moment. Okay, so far so good. We have implemented 3 methods, and what is common with all of them? Well, we don't have a request body. We have response body in 2 of them, but we don't have request body. And if we will go to a familiar Vertx Web documentation and just scroll down in the left list until we will find this request body handling, and let's go there, you will see that in order to get a request body in our methods, we need to specify this body handler. So the body handler is a component that allows you to retrieve request bodies, limit body sizes, and also handle file uploads. So you should make sure that a body handler is on a matching route for any request that requires this functionality. So a good news here that you don't need to specify body handler for each and every method that actually requires functionality. No, you just need to specify it once, and then you could reuse it in all methods that require this request body handling. So how you could get the request body? Well, Vertx provides us 3 ways. We could get a JSON by using the get body as a JSON. You could get as a string, or you could just have as a buffer using get body. Well, if you're coming from frameworks like Spring, you know that Spring allows you to automatically serialize another way to convert JSON into POJOs. But this is not how we will do it in Vertx, and it's not a preferred way. Partly it's with the JSON serialization limitations of Jackson, and partly is the way how we want to implement server-side validation in Vertx. So what we will do here, just like to give you a brief idea, we will use this getBody as a JSON method. So we'll use this getBody as a JSON method, and then we'll get a JSON object, and we will manually construct entities. So we will manually construct our DTOs instead on rely on Jackson serialization. So let's see how we could use this request body handling with 2 remaining methods that we have: create and update projects. Okay, 2 methods that still remain. This is create project and update project. So I group them together into one group because what we need here, we need to get an access to the request body. And in order to do this, we need to utilize what is called body handler and what we have discussed in the previous subsection of this episode. So let's go back to the WebVerticle and let's, without further ado, start an implementation. But the first step, as we have discussed, we need to add this body handler. It is important that we add this body handler before our route definition, so it will be the first in the routing chain. So how we could do it? Well, let's add another line of code, and we say router, and then instead of using these methods like delete, get, post, etc., put, what we do, we will say route, because we want to apply this body handler to any methods that would go to the given address. So not only to put, but also to post. So we use route, and then we specify an address. So all routes that go to the specific address will have an access to the body handler. So it is a good practice, because what we need to do, we need to specify body handler actually once, and then we could utilize it to any request that requires a body. We will use what is called a wildcard. So that means that to all our routes it would apply. So then we say handler, and what we do now, we say body handler create, and we use this static method in order to create a new body handler instance. And now what we could do, we could have an access to the request body by using this body handler. So let's add another method, and it will be a post method. So say route post, and here we say project, so it will be just generic project's resource name, and then we say handler, and we get this routing context argument. So first thing first, we need to have an access to the request body. How we could do it? Well, as we discussed, we have 3 ways, and what I will do now, I will use a get body as JSON. So we could have a JSON object, and we say here body, and now we say context get body as JSON. And now what we will do, instead of using built-in JSON serialization, because it's not a good way, I would construct our project DTO instance manually. So how we could do it? We know that we have a project DTO definition. If we go to the data, to the model, and here we have a project DTO. We have 3 class variables. One would be ID, the second user ID, and the third one will be name. Well, when we post in new data, we don't have ID yet. Also, it is a good practice that user ID we get from the principal object. But again, we don't have principal in this episode, and we need to pass this user ID and use this name as a part of the body payload. So let's go to the WebVerticle, and let's get a new integer, which would be user ID. So how we could do say body get integer, and here we say user ID. So the next step is to get this this name of the project. So it will be a string. So say string name, and say body get string, and we say name here. So now we could construct our project DTO. So say project DTO, and we say payload. So and now we create a new project DTO. The first value, of course, would be null. The user ID would be user ID, and then we pass a name. So now what we could do, we could utilize the project service in order to write this data to the database. So we say project service, create project, and we pass this payload. And then we specify handlers on success, which would be result, and then we pass this code block. And let's copy this on failure handler as well. So you see that I just copy and paste this on failure handler everywhere. Well, it's not a good practice. And what you want to do, you need to have a unified error handling. In order to learn how to do it, I highly suggest you to check my book Principles of Vertx 2nd edition, or you could check one of my courses on Vertx or cloud applications development in general, and you could find different practices how you could implement a sufficient error handling in your cloud systems. But without further ado, let's deal with the result. So what we start with, as you remember, the createProject methods will return us this result, which would be actually project DTO, another project DTO that we get from the data layer. So now what we say result. Actually, we say it's response body. It would be different. It would be better because now we have result variable here, and we say JSON object map from, and we get this result. So this would be response body. This is what we want to write to the output, to the response. So now we say context response set status code 201 created, and then we say end. And we'll say here response body and code. So now we have this implementation of the post functionality, and what we could do now, we could write an API test to verify that it is running as expected. Okay, now without further ado, let's implement a test to verify the createProject functionality. So inside our WebVerticleTest class, let's add another test case, and we call it createProjectTest. And as always, we have 2 arguments here. The first is Vertx instance, and the second is Vertx test context. So now, as always, what we start with, we need to specify a mock data. A mock data that's actually our project service will return. So we say project DTO, and we say project. And now we say project DTO will pass integer as ID, integer as user ID, and string as name. So say my project. So any data could be used here. So the next thing, what we need to do, we need to specify a Mockito behavior. So we say Mockito when project service create project, and we pass here project DTO. Actually, we need to specify Mockito any first. So project DTO class. sorry for this mistake, and then we return a future, succeeded future that wraps this project. So this will be a quite long chain, so let me maximize my code editor. So now what we need to do, we need to pass this familiar context verify code block, like we always do with Vertx. And inside this block, what we will do, we will call a client in order to post apps. Remember, we use an absolute URI. So we say HTTP localhost 8080 port as we define, and then we just say projects, because remember that our address is a projects. So now what we do now, instead of using this send methods as we did before, because we also need to provide a body. So how we could do it, we say send body, so it's send JSON object, and now we need to provide a JSON object. So how we could do it? Well, we could say JSON object map from, and we say here project, and then we could specify on failure and on success handlers like we do it always. So say on failure, and we say context fail now, and on success, what we want to do, we want to verify, first we want to verify status code. So say in status code, and say result status code, and we want to verify that the status code as we have here is 201. So what we do now, we want to verify that this value is 201. How we could do it? Using assertions. So assert equals 201, and we pass the status code value here. So now what we could do, we say context complete now, and let's run this test to verify that the status code is 201. And this failed, because what we have here, we have this problem with the path. So let's fix it. What exactly was the problem? Well, if we go back here to the router route, we have here a wildcard, but this path should start with a backslash. So now let's go back and let's run this test again and verify that now it is passed successfully. But there is one thing that especially here makes sense to check. Well, it also makes sense in get methods, but I would like to focus on how we could assert also a result body. Okay, so far what we did, we tested only a status code. And what we also could test here, we could test actually a result body. So how we could do it? Let's, instead of using it in the createProject let's go to the findProjectById exist test, because here it really makes sense. So what I'd like to do here, I would like to check that the result body, the response body that we have here, is actually this one project DTO that we actually have. So how we could do it? Well, first thing first is we need to have a JSON object, and we say body. And now the result has a special method that uses a body as JSON object. Well, also we could have this body as JSON, body as buffer, JSON array as string. Well, we don't use this body as JSON because actually it requires us to use JSON, and we don't want to use it. We don't want to do it. Actually, for these purposes, for quite simple objects, using body as JSON object is enough. So now what we could verify that this JSON object has an ID, a user ID, and a name. So let's do it. So it's assertions. Assert equals, and the first one would be ID. So we say a project ID, and we say body get integer ID. So the third one would be assert equals project user ID, and we say body get integer user ID. And finally we have a name, so say assertions, assert equals project name, and we say body get string, which would be a name. So now we have this body assertion, so we don't only assert a status code, but we also assert a body. So let's run this test and check how it would work. So now you see this test passed because we verify not only status codes, but we also verify this body. And this is how you could do it. So now let's finish with our implementation and let's go and implement the last remaining method. Okay, the last remaining method that we have here is the update project. And technically the idea of update project is the same as we have in the create project. And usually when we come to Spring Data repository, for example, it uses the same methods in order to, under the hood, it uses the same method to update projects. It just verifies that is the entity has ID or not. If ID is presented, we use an update functionality. If you remember in the previous episodes, let's go back to the data layer. And here we have this project repository implementation. So what we have here, actually, inside the create project, you could see that, let me maximize the screen for a moment. You see that inside the create project, we use this persist method from the Hibernate in order to save this data in the database. However, when it comes to the update project, what we actually have, we have this quite more complex functionality which requires us to use a criteria update. And basically what we have here, we just update this name because this is only makes sense to update. And we have talked about this, that we could not update ID because it's a technical unique identifier. We also could not update user ID because this means an ownership of this project. And what we could do, we could only update a name. So this what really makes difference with our solution in this particular episode and the solution that has what is called principal. Because as you see, we just need to have this name inside the request body, but we usually grab this user ID from the principal, like we did it previously when we implemented the project service. So here you see we have this principal, yeah? So this is the way how we get a user ID. So this is the way, but it's not the way we do it in the simple project service, because inside the simple project service, we don't have this data, and everything goes to the project DTO. So that means that implementations that we use in this particular subsection would be a little bit different. It's just a small note before you will apply this solution to your cloud systems. So let's go to the WebVerticle, and basically what we do, I would like to copy all this stuff that we have and let's duplicate it. So what I would like to do, first I change this method. This is a tricky moment because you know we have a distinction between put and patch, and especially if you use frameworks like Django, especially Django REST framework, they have this difference even in their classes that they supply, this class-based views. And well, technically, what we want to do, we want to use this patch because we don't have enough data to change, we just have a name. But I would like to specify more generic put here. So now, all we have here is the same. The only thing, this ID should be changed. So we say integer ID, and we say body get integer ID. And now we specify here an ID. The second thing is to change the create project with update project, and basically here would be instead of 201 we need just to say 200, so the data is updated. Everything else remains the same as we did in the post method. So again, let's go to the WebVerticleTest and let's implement the API test for this functionality. So as I have said, the only remaining test method is the updateProject And what we could do actually, as we did in the implementation, let's just reuse the same createProject functionality because there is no significant difference. So let's copy all this stuff and let's duplicate it. But let's first rename it with the update project. And then we need to specify a Mockito behavior. So instead of create project here, we'll say update project. And then instead of post ABS, we use put ABS because remember we use a put method here. So everything else remains the same. The only exception is that instead of checking for 201 status code, we use 200 because remember here we have the status code 200. So let's run this last test and check that everything works as expected. So you see that this test passed and we now have this update project test functionality. So this is the way we implement this method, and we write an API test. Okay, so far so good. Just a small conclusion here. You see that throughout this series, throughout several YouTube videos about Hibernate Reactive and Vertx 4, we did a lot of work. We have implemented the data layer, we implemented the service layer, and finally today we implemented this WebVerticle, which is responsible for the web layer. But as you could notice so far, what we did, we used these tests in order to run our application and to verify its behavior. Well, we need to write automated tests, and it is important to write automated tests, but nothing could really replace the pleasure of running your application and to connect with it, for example, using HTTP client or even single page application. Why not? But what we have implemented so far, we just implemented separated parts, and in order to run this as an application, what we need to know about the thing that is called application vertical pattern. So you see here, we have here this main vertical, which is a legacy from the Vertx starter boilerplate code, but this would be also a skeleton for our application vertical. Of course, in this part we already talked a lot, and would be really dishonest to put also application vertical here. So I would like you to subscribe to my channel and wait for another episode when we talk about how we could use application vertical pattern, how we could assemble everything together, and how we could run our application that we wrote with Vertx and Hibernate as a standalone Java application. So this will be a topic for the next episode. Don't forget to subscribe to my YouTube channel, and don't forget to check also my book Principles of Vertex, 2nd edition, and to check one of my courses on Vertex development and cloud applications development in general. So see you soon.